Hey there, science enthusiasts! Have you ever wondered about the bizarre phenomenon where hot water seems to freeze faster than cold water? Today, I'm diving into the curious case known as the Mpemba Effect. All right, let's start with the basics. Imagine you have two containers of water, one hot, one cold. You place both in the freezer at the same time. Surprisingly, the hot water appears to freeze more quickly. This counterintuitive occurrence has puzzled scientists for centuries. So, where did the Mpemba effect get its name? Back in the 1960s, a Tanzanian student named Erasto Mpemba observed this odd behavior while making ice cream. His teacher dismissed it initially, but Erasto's curiosity led to more investigations. Eventually, the phenomenon was named after him. Now let's explore some possible explanations. One key theory involves evaporation. Hot water tends to evaporate more rapidly than cold water. As the water evaporates, the overall volume decreases, leaving less liquid to freeze. With less water to cool down, the remaining liquid can solidify faster. Another idea is related to convection currents. In a container of hot water, convection currents are more vigorous. These movements can lead to a uniform cooling process, allowing the water to reach freezing temperatures more efficiently. Cold water, on the other hand, has less active currents, potentially slowing down the freezing process. Next, let's consider the role of supercooling. Water can sometimes be cooled below its freezing point without turning into ice. This state is called supercooling. Hot water might avoid supercooling because it loses heat rapidly, passing through the supercooling phase quicker than cold water. Another potential factor is the presence of impurities. Hot water can dissolve more impurities compared to cold water. As the hot water cools, these impurities can form nucleation sites, prompting ice formation. Cold water, with fewer impurities, might not have as many nucleation sites, slowing down freezing. It's important to note that the Mpemba effect doesn't always occur. The environment, container material, and other variables play significant roles. In some conditions, cold water might freeze first, so it's a phenomenon full of fascinating nuances. Scientists continue to study the Mpemba effect to fully understand the underlying mechanisms. While there's no single answer, the exploration of this phenomenon teaches us valuable lessons about the complexity of nature. So next time you fill your ice cube tray, remember Erasto Mpemba and the intriguing effect that bears his name. The world of science is full of surprises, and the Mpemba effect is a perfect example. Thanks for tuning in. If you enjoyed this deep dive into the Mpemba effect, give this video a thumbs up and subscribe for more mind-bending science content. Until next time, keep questioning and stay curious.